Introduction. Setting the scene. Imagine a crimson sky, the thin atmosphere tinted with hues of dust and sunlight. A robotic lander touches down, its descent captured by cameras transmitting history back to Earth. Slowly, a hatch opens. A human foot steps onto the Martian soil, imprinting a moment as monumental as Neil Armstrong's first step on the moon. This is not science fiction. It is NASA's vision for 2030, a daring dream to make humans interplanetary. But how will we get there? Let's break it down. The road to Mars, Artemis program. Before humanity can walk on Mars, we must master the moon. NASA's Artemis program is the cornerstone of this journey. Launched in 2022, Artemis I was an uncrewed mission to test the Space Launch System, SLS, and Orion spacecraft. The successful completion set the stage for Artemis II and III. Why the moon first? The moon serves as a testbed for Mars. Its proximity, 3 days away compared to 6 months to Mars, makes it a safer training ground for long-duration missions. Technologies for sustainable living, like water recycling and radiation shielding, are being tested in lunar conditions. Artemis III, Gateway to Mars. By 2025, Artemis III aims to land humans on the lunar South Pole, where water ice resides. This mission will refine techniques for mining resources and building habitats, skills crucial for Mars. The Artemis program also involves the Lunar Gateway, an orbiting platform around the moon that will act as a staging point for deep space missions. Technological marvels for the Mars mission. Reaching Mars requires groundbreaking technology. NASA's plans involve a synergy of international collaboration, private industry, and scientific innovation. Spacecraft. Orion. This crew vehicle, designed for deep space, will ferry astronauts to the Lunar Gateway and serve as a key component of Mars missions. Starship. Partnering with SpaceX, NASA envisions the Starship as a Mars lander. Its reusability and capacity to carry heavy payloads make it a game-changer. Propulsion. Traditional chemical rockets are too slow and inefficient for Mars. NASA is investing in nuclear thermal propulsion, which could reduce travel time and increase payload capacity. Sustainable living. Habitat modules. Designed to shield astronauts from radiation, these modules will also recycle air and water. They'll be tested on the moon before deployment on Mars. Food production. Astronauts will rely on hydroponic systems to grow fresh food during the mission. Spacesuits. Current designs must evolve to handle Mars' unique challenges, like its fine, sticky dust and colder temperatures. The XCMU, Exploration Extravehicular Mobility Unit, is under development to meet these needs. The challenges of Mars. Landing humans on Mars is an audacious goal fraught with challenges. Distance and isolation. Communication delay. Messages take up to 20 minutes to travel between Mars and Earth, making real-time guidance impossible. Psychological strain. Astronauts will face isolation for over a year, requiring robust mental health strategies. Landing safely. Mars' thin atmosphere makes landing difficult. Parachutes alone aren't enough. NASA is developing retropropulsion and inflatable heat shields to ensure safe landings. Radiation. Without Earth's magnetic field, astronauts will be exposed to harmful cosmic radiation. NASA is exploring protective materials and medications to mitigate these risks. Surface operations. The Martian environment is harsh. Dust storms, extreme temperatures, and a lack of oxygen. Robots will scout landing sites and assist in building habitats before humans arrive. The human element. Stories of astronauts. Every mission is powered by human courage. The Mars mission will be no different. NASA is selecting astronauts with unique skills and resilience to embark on this historic journey. Meet the crew. The Mars team will include a mix of scientists, engineers, and medical professionals. Their training includes wilderness survival, robotics, and long-duration simulation missions in extreme environments like Antarctica. Personal sacrifices. These pioneers will leave their families for years. Their dedication echoes that of earlier explorers who braved the unknown. Inspirations. Stories from the Apollo era inspire this new generation. The Mars astronauts will carry mementos, perhaps a patch of lunar soil, symbolizing humanity's enduring quest for exploration. Mission timeline. Step by step. Here's how NASA envisions the Mars mission unfolding. 2030. Launch day. A giant rocket lifts off, carrying the crew and cargo toward Mars. The journey lasts 6 to 9 months, during which astronauts conduct experiments and prepare for landing. Arrival on Mars. Upon reaching orbit, the crew transfers to a lander. Touchdown occurs in a pre-selected region, likely near polar ice caps for access to water. Building a base. The initial mission will last 30 days. Astronauts will test equipment, conduct research, and begin constructing habitats for future missions. Return to Earth. After their stay, the crew launches back to orbit and begins the long journey home, bringing samples and data. Why it matters. The bigger picture. Why spend billions to send humans to Mars? The answers lie in humanity's drive for discovery and survival. Scientific knowledge. Studying Mars helps us understand Earth's history and climate change. It may also answer the age-old question, are we alone in the universe? Technological spin-offs. Innovations for Mars often find applications on Earth, from medical devices to sustainable energy solutions. Inspiration. A Mars landing will inspire a generation, just as Apollo did. It represents a shared human achievement, transcending borders. The future beyond Mars. Mars is just the beginning. NASA envisions a future where humans venture even further, exploring the moons of Jupiter or Saturn. Colonizing Mars may lay the foundation for humanity to become a multi-planetary species. The visionary drive behind NASA's Mars mission. Humanity's quest to explore Mars is fueled by more than just scientific curiosity. It's an extension of our innate desire to push boundaries. Mars represents the ultimate challenge, a frontier fraught with immense hurdles yet brimming with possibilities. NASA's 2030 Mars mission reflects decades of planning, collaboration, and innovation, standing on the shoulders of pioneers like Galileo, Kepler, and the Apollo astronauts. As Earth faces challenges like climate change and overpopulation, Mars emerges as both a scientific wonder and a potential lifeboat for humanity. But transitioning from dream to reality requires addressing questions that challenge the limits of our ingenuity. How do we survive on a hostile planet? Can Mars teach us more about life on Earth? And perhaps most intriguingly, can it sustain life beyond our own? The Artemis program, humanity's lunar laboratory. The Moon has always been the stepping stone to Mars, not just in distance but in complexity. While the Apollo missions of the 1960s and 70s proved we could land on the Moon, the Artemis program is a leap forward. This time, the goal isn't just exploration but sustainability, a critical step in preparing for Mars. Lunar Gateway, a space outpost. The Lunar Gateway will serve as a staging area for deep space missions. This orbiting platform is a collaborative effort involving NASA, ESA, JAXA, and other international partners. It will house crew members, act as a refueling station, and test systems designed for Mars.